Mark Kallegman is Emeritus Professor and also founding director of many things, among them Research Ethics Program and the Center for Ethics and Science and Technology at the University of San Diego in the USA. He has taught many courses and trained the trainer courses on research ethics and research integrity. He, in many ways, is one of the nesters of our emerging and still young field. He also was instrumental in making the Asian Pacific Research Integrity Network happen, which is a lively organization, a network of people who care about research integrity and research ethics in Asian countries. But it's on the Pacific coast, so also the USA is part of that. And today, the topic of Mike is how to align interventions and goals in research integrity, likely including research integrity education. So I'm curious what you have to say, Mike. The floor is yours.
So thank you, Lex, for that very kind introduction. And I'm curious to hear what I have to say as well. So let's see how this goes. I'll begin by noting that while it's early in the morning for me, all of you have had a long day. So I know that there is a risk of meeting fatigue at this point. I will do my best to keep things somewhat lively by moving quickly through a number of different pieces to my argument. And the slides which I've sent to Dorian, I'm more than happy for anybody to have them if they would like to see them later. So I'm going to start with a very personal story. This happened to me. It was in the last century for the younger members of the audience. That was a long time ago. When I was a graduate student, I had finished my master's degree and was interested in working in an area of pharmacology. And I found a professor in the Department of Pharmacology. Anyway, I found a professor in the Department of Pharmacology who was doing some really exciting work. He had discovered, apparently, a receptor in the brain for a drug that was being used clinically for a particular condition. And the idea at that point of finding a specific receptor for that drug was really important because it might help provide insights into what drugs would work, how the disease worked, and so on. And the experiment, without going into a lot of detail, involved varying the concentration of the substance you're looking at and seeing how much was binding to the tissue that was from the brain. And what you would hopefully normally see is that at low concentration, you wouldn't see much binding. And then as you increase the concentration, you displace what was being bound there. And this is the kind of curve you would expect to see. Well, when I tried the experiment that he'd been doing, I got results that looked completely noisy. I mean, every concentration I chose seemed to be just random information. And I was concerned, this was a new field for me, that I simply wasn't doing it right. I spent days and nights trying to solve this question. And the end result of that was that I couldn't fix it. I couldn't find out why I wasn't getting something to work. So I asked the professor if he had any other ideas, and we discussed it, and he suggested I could look at his raw data to see what he had been looking at. And he said he was going to be out of town for the weekend, and I could go ahead and look at the data that were in his office. So I pulled out the data, started looking through it. His data looked very much like mine, except before he presented the data, he did some editing of what he had and ended up with a really relatively clean picture. So at that point, I did not know my career was going to shift into the area of research integrity and ethics. I didn't really know what to do. I went and asked another professor who I had worked with previously what I should do. And he said, I don't know what's going on there, but why don't you come and work with me? And I did, and I never went back. I never blew the whistle. I never thought about doing anything further. And the reality is, to this day, I don't know. Was this professor willfully, intentionally making up data? Was he doing something wrong and didn't know he was doing something wrong? Was there something more to this story than I actually knew? In either case, there was a mismatch between the story he was providing and what I was getting for data. So behind this, I suspect all of you might right away start thinking about research misconduct. And that seems to be what we focus on when we say, what is research integrity? Well, it's not committing research misconduct. I'm going to make a case today that we should be thinking about this much more broadly. But before I do, I'll note that research misconduct does occur. These are examples of cases from countries around the world, very well-known cases, those countries that often had been very prominent and usually involve people doing things repeatedly. We had a case at my university, University of California, San Diego, actually just before I started working in this field. That was somebody who had basically falsified and fabricated data for numerous papers. You had a case in the Netherlands, Diederik Stapel, which is well known internationally as well. But when you look at those cases, you realize that at first that it seems, oh, there's so many that must be really frequent. But I don't know that it's entirely that frequent. And more importantly, I think on the other hand, we need to get away from a view that those people who are doing this are somehow just extraordinarily bad apples. We have that metaphor in the United States. I don't know if you have the same one, that there's something wrong with this particular apple. And if you just get rid of that apple, then everything else will be fine. Dan Ariely in the United States from Duke University has made a very compelling case with his group's experiments that in fact, given the opportunity, most of us will engage in beneficial dishonesty, not just some people, but most of us. There is, that means it's not just about someone else, it's about all of us. The picture I've illustrated here is from a cartoonist named Walt Kelly. This cartoon goes back to the 1970s. In 1971, he illustrated this cartoon with his character Pogo, who is looking at a pile of trash that's accumulating in the world around him. And he realizes it's not somebody else that's doing it, it's all of us. We have met the enemy, and he is us. And I hope, if not, no other message you'll take away from today, it's that when we think about what we're trying to work on here, it's not that we're trying to solve the problem of one or two individuals who are bad apples, but that the risk is for all of us. So in the remaining 20 minutes or so I'll be speaking, I'm going to talk a little bit about reproducibility and statistics as sort of roots of problems that go beyond just research misconduct. Talk about the problems that allow us to make mistakes and do things that are wrong, including incentives, blind spots, and rationalizations. And at the end, speak briefly about solutions and what we should be doing given what we have learned. So let's talk about reproducibility and statistics. And the key here is that I'm making the case, I hope successfully, that research ethics is not just about research misconduct. It's not just about avoiding research misconduct. Internationally, there has been a lot of conversation in the last, say, 5 to 10 years about reproducibility, the inability of one research group to duplicate or to reproduce what had been done and published by another research group. There is some question amongst older, more senior scientists about whether this is a new problem or not. But when researchers were asked in 2016, do they believe there's a reproducibility crisis? Over half said there is a significant crisis. And about a third said that or a little over a third, said there is at least a slight crisis. So there was this perception of an overwhelming percentage of scientists that this is a problem, that this is something we should be worrying about. And one of the arguments that is at the base of this was produced by Ioannidis, arguing that in 2005, so this is 16 years ago now, arguing by the way, theoretically, that research findings that are published are more often than not going to be false because of cases where we have studies that are too small, effect sizes that are small, not choosing in advance what relationships we're going to look for, but being able to pick and choose afterwards, having flexibility in designs, definitions, outcomes, and analytical modes, when there are financial and other interests that are pushing us perhaps towards particular solutions, and when many teams and groups are chasing statistical significance. There's a compelling argument here and this is theoretical at that point, that there are reasons why we would expect much of what is published to not be true. And this has been seen now empirically in a number of fields. In psychology, for example, a paper was published a few years later called False Positive Psychology, basically echoing exactly what Ioannidis was concerned about, that undisclosed flexibility in data collection and analysis can allow us to produce almost anything as statistically significant. So the conclusion, in many research cases, a researcher is more likely to falsely find evidence that in fact it exists than to correctly find evidence that it does not. And then another paper tried to look at 100 experimental studies that had been done previously to see whether they could reproduce them. And only 37% of those studies were able to be reproduced, still in a statistically significant way. Now, those of you who have worked with or in the hard science, so-called hard sciences, medical science, for example, might say, well, that's psychology. What can you expect of psychology? It's a soft science. And no wonder only 37% of the studies were statistically significant. However, around the same time, short time later, a couple of studies were published, one from Bayer, a drug company, in which they looked at 67 projects, mostly in the field of oncology, and found that almost 2/3 of the projects were characterized by inconsistencies between the published data and what they found in-house. Only 33% were at least partially replicable, arguably similar to, but a little bit worse than what I just described for psychology. And Begley and Ellis, in a paper with Amgen, did something similar and found that only 6 of 53 of the papers they looked at, 11%, were able to be reproduced. So this brings us back to a question, a statistics sort of question of how do we decide what is true? What do we publish? When do we say something is the truth? And we characterize what is published as if it is true. Well, the standard we use is this p less than 0.05 standard. There are journals and there are places where people are being less tied to that specific cutoff. But the reality is we have a cutoff. We say at this point, we think something is reliable. Well, how reliable is this standard of 0.05? I've thought about this a fair bit and realized that means that you have a 1 out of 20 chance of being wrong. So here's 20 opportunities. 1 out of 20, it's not a lot, but you look at that and you think, wait a minute, if I was at an intersection of a street and somebody told me I would have only a 1 out of 20 chance of surviving if I crossed the street, I suspect most of us would say, I would like better odds than that. That's not very good odds. Our standard for what is true is actually fairly low. And that standard, when you think about where it comes from, Ronald Fisher, famous statistician from over a century ago, said that, this is p equals 0.05 or 1 in 20, in his view, was a convenient point as a limit in judging whether a deviation we saw should be considered significant or not. And the irony here, according to Nuzzo, describing what Fisher was looking at, is that when he introduced this, he did not mean it to be a definitive test to tell us, here is the truth. He intended it only as an informal way to judge whether evidence was worthy of a second look. This is, in some ways, one wonders why we should even publish at that point. We should be using that as a pointer in the direction we should be going, as opposed to publishing it as if it's the truth. So taking what I've just said about both research misconduct and these other questions about how, without even committing research misconduct, we do things that might result in research that is simply not reproducible, not because we've lied, not because we've cheated, but because we've perhaps not recognized the limits of our science and the limits of our own abilities. We're really doing some things that are wrong. We're perhaps misusing statistics, for example. So how does this happen? And I'm going to talk briefly about 3 categories of things that are factors that result in less than the best science. Let's begin with this overall view of why would we choose to do something that's unethical? Well, in the case of research misconduct, where it's knowing and intentional, or in the case of even poor research practices, I'm going to submit to you that I suspect that that is, while unethical, it's probably unusual that people intentionally, knowingly do these things. You could say, well, how could somebody not know they were doing these things? How can we do something unethical or wrong without knowing? And the answer is these incentives, blind spots, and rationalizations, which I suspect, just from my own experience, are really frequent. They characterize the world we live in. So incentives. To talk about incentives here, I like to go back to Charles Darwin and on the origin of species, which he said any variation, if profitable to an individual, will tend to the preservation of that individual and therefore become characteristic of that species. The scientific community rewards are based on what we measure. So what do we measure? What do we reward? What is profitable in scientific community? And as Biaggioli said in a paper just last year, we hide behind the rhetorical shield of being objective by using metrics. And they become a disciplinary technique we use to judge people's work while we're failing to measure anything worth measuring. What do I mean by that? One example is the journal impact factor, which those of you who are publishing work, I am sure well aware of and probably pay close attention to. The origin of the journal impact factor was Eugene Garfield back in 1955, who was interested in finding ways to characterize which journals a library should keep and which ones they shouldn't keep, which were cited most often. He came up with this new index in 1955. The author of this impact factor went on to say in this paper in 1998, the source of much anxiety about journal impact factors comes from their misuse in evaluating individuals. In many countries, I, meaning Eugene Garfield, have found that in order to shortcut the work of looking up actual, real citation counts for investigators, the journal impact factor is used as a surrogate to estimate the count. I've always warned against this use. There is a wide variation from article to article within a single journal, as has been widely documented. The key here is that when you see as the major factor for you to succeed is the impact factor of the journal you publish in, most important thing is to get published in that journal by whatever means necessary, as opposed to doing work that others can reproduce and can see as being done well. All you need to do is get into those journals. Second factor is, beyond those incentives is the risk that we will never even see the problem that's there. There's this great book by Bazerman and Brunzel written about a number of major events that had occurred, and looking at them, what they discovered, major problems, like the housing crisis that started in the US with mortgages that are being written for people that should not have been getting mortgages, and the result was a financial crash. What they discovered was that people just didn't see what they were doing because they were focused on their incentives, on the reward system, on other things. And because of that, Bazerman and Brunson pointed out that ethical interventions, kinds of things that many of us are trying to promote, those have failed and will continue to fail because, and I think here we should say if, they are predicated on a false assumption. And that assumption is that individuals recognize an ethical dilemma when it's presented to them. So much of education and research integrity has sort of been premised on this idea that we need to tell people, oh, here's what you're not supposed to do. Here's what's wrong. When in fact, people know very well what's wrong. They just don't see it because they aren't looking at it. They have blind spots. And then as if that weren't enough, we use rationalizations. We are human beings, and human beings this is one of our greatest talents, is to find reasons that when we've done something wrong, it wasn't really something we should be blamed for. So we condemn the condemner, we blame whoever is accusing us. We deny responsibility. Our action or the consequences that we're talking about were unintentional. We deny there was any injury to anyone. It was little or no harm to others, so that we shouldn't worry about it. We deny there was even a victim. They deserved it because of bad things they've done in the past. This is just the punishment they deserve. We claim entitlement. We say this is what we are due from a moral perspective. We should be repaid, or we should be repaid for injustice that's been done to us in the past. So it's okay for us to do this. Or we appeal to higher loyalties, saying we're just following orders. This was a defense used by some of those tried in the Nuremberg trials after World War II, saying they were just following orders. Or some people might say, here's my moral code. I need to always tell the truth, no matter what. I need to always tell the truth, even if it's some situation where the truth might cause more harm than good. And finally, we claim things are common practice. We say others do it with impunity. This is not something that one or two bad people do. What I've listed here is what we all do. In the US, I don't know how things are in the Netherlands on the freeways, but in the US, almost everybody drives over the speed limit. And they would argue through rationalizations that it's fine, and others do it with impunity. They don't get caught, they don't get blamed, so it's okay. So I want to move now to a little bit of discussion about solutions. So I've hopefully laid out for you that we have, in many ways, challenges that we're worried about research misconduct, but we're worried about the way we do research and the incentives and system that we now have in place that we use. So when we think about this, we should think more generally, not just about research misconduct, but about the various ways in which our work that we produce is not reproducible. It's not useful work. So one of the reasons why that might occur would, of course, be because somebody trying to reproduce it is not doing it right. That's, of course, something we should worry about. And another issue could be that they are simply making things up. If it's fraud, it isn't surprising that we can't reproduce it. But more commonly, we are probably dealing with failures of design, failures of how things are documented, failures of the analyses that are done, failures in how things are reported. And these could be because somebody intentionally did this, but usually that would probably be more like fraud, or it could be that it was unintentional. As I said before, we can do things that are wrong because of the incentives, because of the blind spots, because of our ability to rationalize away what we've done. And there may be unknown factors that we don't know that are the reason something can't be reproduced. Well, if you look at this, there is an opportunity here for us to do something to really improve the quality of how we deal with our research. And that is to look at this one category, which is those things that are done that are unintentional. How do we decrease the risk that we won't see what we're doing wrong? If I said there's blind spots, I mean, how do we get around the blind spots? And I'm going to make the case that the solutions here, the kinds of things we should be thinking about for interventions, are useful. They will actually make a change. They are easy and often inexpensive. Not all of them, but many of them are. And they aren't typically done. It's sort of a tragedy that these three things together all exist at the same time. We have a solution to this in sight. So how can we do better? Well, here are some selected examples, and I don't mean these to be comprehensive, but these are some kinds of things that you might consider. We could change the system to reward, if we could change the way we approach things so that researchers see themselves as being rewarded for the right things instead of the wrong things, that would move us a tremendous way towards doing better about how science is done. So some simple things here. Foster an open and transparent research environment. The extent to which we talk about privacy and keeping things confidential, keeping things hidden, personal ownership of things, the more likely it is that somebody can fool themselves because they aren't exposing what they're doing to the light of day. We should be teaching about and practicing the design of our experiments in ways that minimize the risk of bias and using adequate controls. When I started getting into the ethics field and started looking at what I had been doing in the biomedical sciences, mainly in studies with animal research, I noticed that many researchers who worked with animals thought there's no need to blind my study because I'm a scientist. I'm objective. I don't have to worry that I might be biased in what I see in my experimental study. But in fact, we scientists are human beings. And as human beings, we are at risk of bias. And even with some of the most objective measures, we have a risk of seeing something that isn't there. And we will find the way to pull it out. We will, without ever realizing it, it will be a blind spot. So we need to find ways to blind ourselves so we don't have the risk of that bias interceding or interfering with our experiments, and having adequate controls so that we know that if we've done our experiment properly, that if there was an effect to be seen, we would have seen it. And if there wasn't an effect to be seen, we shouldn't have seen it. Keep good records. Those of you who have looked closely at cases, allegations of research misconduct, know that they are very often characterized by just horrific record keeping. It is almost impossible to figure out what was done or what wasn't done. If we are keeping good records, we are keeping a check on ourselves. We have something that, and if we're being open and transparent, our colleagues can see that. It decreases the risk of missteps. Of course, we need to understand and use statistics appropriately. One of the things that I know from talking to many people is that in psychology, for a variety of reasons, historical and otherwise, they spend a good deal of time learning about statistics and learning about it in depth, deeply. In the biomedical sciences, it's almost too often an afterthought. We don't really understand what we're doing. We just think of it as a hoop we have to jump through in order to get our paper published. Report accurately what was done. Sounds simple, but so many of us just don't worry about providing the necessary details so somebody else can reproduce what we're doing, for that matter, so we could reproduce it again if we wanted to do it again. And to provide adequate training and mentoring for the next generation of scientists. This is where this all sort of matches up. I mean, where does this occur? How do people learn to do these things? And unfortunately, too many faculty researchers think, oh, my students, my trainees working with me, they already know these basic things. Well, the reality is they don't. They haven't actually been taught those things because nobody is teaching them in context, which is what we should be doing. We should all be learning these things together. And then finally, all of this should hopefully allow us to align criteria for success with the quality of our scholarship. So also back in the last century, Richard Feynman, some of you may know him as a Nobel Prize winning physicist, gave a commencement address at Caltech. And in his address, he said the first principle is that you must not fool yourself. And you are the easiest person to fool. Very reminiscent of the idea that this is not just about ethics, it's about good research practices. And the problem is not someone else, it's all of us. So I think I was supposed to stop right about here. So I'm going to thank you for your attention, and I would be happy to discuss with you on how we can do better.
Mike, this has been entertaining, insightful, and you revisited a few of the basics of our field. I like that, and drawing lessons learned, adding some anecdotes and interesting stories. There's a lot I want to ask you myself, but let's start with one of the people in the Q&A section, and there is still room for the others if you want to pose your questions to Mike Kalichman. And that is maybe a bit tricky one as well, Mike. Gino, he says, well, I noticed that you mentioned Dan Ariely in your introduction slides. Now, didn't something happen with one of the publications of Dan Ariely?
I already
Did you do this on purpose, or what happened?
So, I don't know what happened because I don't know Dan Ariely personally. I was not working in their research group. Very briefly, I don't know if it's been discussed in your meeting today, but for those of you who don't know, there has been a case in which a paper published a number of years ago from Dan Ariely's group, um, uh, people became concerned that what they had found didn't seem right. And in fact, I think here there's room for giving Dan Ariely tremendous credit in members of his group, because they not only published their own paper saying we no longer think we can rely on these results, there's something that's not right, but they included with that the entire data set so that anybody could see what they'd done. This is an example of openness and transparency. And the result of that is that some people then did go through that data set very closely and discovered some very damning things. Somebody, I'm pretty likely intentionally, had manipulated that data set. And for whatever reason, Dan Ariely is not able to identify or find who that was that provided the data set to him. And he was the one who then provided the data set for the work that they did. So I feel like the answer is open as to what happened here, but in the story is a good example of openness and transparency can be really helpful, and we can better understand what's going on. It becomes harder to hide something.
Yeah, well, thank you for that. That's also more or less my understanding of the case. You could also say that this case is an instance of another type of blind spot. Well, there's so many things we don't see ourselves, and that might be a question you're willing to answer as well, Mike. What is your favorite way to solve our own blind spots? What shall we do? What are the interventions you recommend to make them visible for yourself and to detect them before damage is done?
Yeah, I mean, so that's easy. I mean, I love the idea of saying, what's my favorite? My favorite is openness and transparency. The more that we talk to other members of our research group and say, here's what I'm thinking, here's what I'm doing, somebody else will be there to say, oh, wait a minute, are you sure that that's acceptable to do that? Or are you sure that that's right? Did you miss something here? And it's not a guarantee, but it's going to go a long way to protecting against what can happen in the middle of the night when you're by yourself and you're sifting through your data set and trying to decide what to do. Openness and transparency, I think, is the answer. And so our interventions should promote that. We should be arguing to people about why they should be doing this, giving them arguments for why they shouldn't worry about being secretive. Many fields are just defined by this idea, I should never share with others what I'm doing because somebody else will scoop me and I won't be able to do as well, and ignoring the arguments that are compelling for the advantages of sharing and being open and talking to others.
Yeah, well, isn't this interesting that you are longer in the field than I am, but I've seen that the intention shifted from FFP, falsification, fabrication, and plagiarism, towards questionable research practices, and then to more responsible research practices. And then it occurred that the root causes of the replication crisis you alluded to so elegantly in your lecture might ask for the same solution as the questionable research practices, namely openness and transparency. And shouldn't we be teaching open science modalities much more than we are teaching ethical concepts and ethical decision-making and handling dilemmas?
Yeah, actually, that's a good point that I did not really underline in this presentation, but to me, the word ethics maybe isn't needed here as much as the words good research practices. I mean, this is what good research should look like. And if you are, I mean, to me, it seems almost self-evident now that being open and transparent, for example, keeping good research records, understanding statistics, aren't those the things a good researcher would do? And somehow we are, instead of doing that, we are hung up on saying, well, it's about ethics and this is only about people who are bad people and do bad things. We all have a lot to learn about doing good research practices.
Yeah, well, Mariette van der Hoven seems to agree. She writes, I tend to agree that a lot is not only rationalized, but also about learning. We need people to learn to see, to point to the blind spots. And would that be teaching ourselves and our pupils, our students, how to detect your own blind spots and your blind spots in the environment would be more important than telling them about codes of conduct on research integrity and the usual stuff.
Absolutely. And in fact, talking about, the failures of research integrity, the research misconduct cases, and beginning with that, in my view, is almost an insult to students who are in the room who think of themselves rightly as good people who want to do the right thing. And now somebody's lecturing me that I shouldn't lie, cheat, or steal. We should move the direction of these conversations to saying, what does it mean to be a good scientist? And here are some things that you probably didn't learn in elementary school about how do you decide who should be an author on a paper? What does it mean to design a good research experiment? What are some of the components of that? So those are some directions that might be helpful here.
Yeah. I've got a question by Tamarinde Haven as well, but I'm not sure I understand it completely myself, so I'm just going to read it, and I hope that you understand it better.
Well, we can ask Tamarinde to repeat. Okay.
Yeah, that's the thing that can happen, of course. She writes, if needed, something that could be interesting is that the authors, I don't know the authors of what, provide some suggestions. Revamped graduate training could push future researchers to appreciate better the uncomfortable novelty of ideas less rooted in established canon. These measures, while not easy to implement across large fields, may help push scholarship off the local attractor, existing canon, and towards more frontiers. And she's pointing to page 4, but I have no clue of page 4 of what. Maybe you have, Mike.
No, I think I get components of this about getting people to think about their research as, not worrying about just staying focused on what everybody else has said is right and true, and looking for different things. But can we ask Tamara to maybe repeat her question?
Yeah, well, she's probably typing as we talk, so let's wait 1 minute for that. And before we delve into that, Mike, the main topic of today is, and your final on our program today, is well, more or less the future of research integrity education. And you've said a lot of things that might be taken into account better in research education courses. So can you maybe make a small list of the 1 or 2 most important elements you want to see more in research integrity courses in the future, based on what you just told us?
Sure. So the first thing that comes to mind is trying to move the conversations out of the course and into the research environment. So in the context of the course, there are 2 ways you could do that, or at least 2. One is to simply make it an assignment that the students in the class need to go back to their research groups and ask their colleagues questions about whatever topic you're working on, such as how do you decide who should be an author on a paper, or why don't we have a policy in our group about how records should be kept, and to discuss that and what that means. Doesn't mean the group is wrong, by the way, but it's something that having that discussion could move a long way to moving that conversation into the group. And the second is to ensure that our courses are interesting enough that people want to take those conversations outside of the classroom, and they know how to take those conversations outside of the classroom. I know that I missed the talk just before mine from Tristan about methods of evaluation and assessment, but I've heard her talk on this topic a number of times before, and it's something that's very important to me as well. One of the things that we do in our courses in San Diego is we ask at the end of the course, as part of the evaluation of the course, we ask the students, how many times after the meetings of this course, did you continue talking about what we talked about in class with others outside of the class? And I'm very pleased to say that a very high percentage, the overwhelming percentage of students have done it at least once, and many of them more than once after the class. They're taking the conversations out. And that is the result of an engaging, interesting, relevant conversation. So I guess if you ask me some things to do, those would be the first two that come to mind as the most important things about a class.
Well, that rings a bell with me. When I'm teaching PhD students, for instance, on research integrity, they often say, hey, this was interesting, this was wonderful, thank you very much. But now please go out and tell it to my boss, to my supervisor and my department head. And this is one of the tricks that people can use and are using, in fact, to engage them in what's happening in class, these supervisors, by having talks outside the classroom. And in fact, it's a very good evaluation question as well for courses. How many conversations did you have on the topic outside this classroom? I really like that. And have you some more recommendations how to engage these supervisors and these busy senior people who seem not to tend too much to take this type of courses?
Yeah, well, so there are a couple of components to that. The first one is that I think in pretty much every university in the world, faculty aren't going to do anything they don't have to do like this. Most aren't, but some are willing to engage. And now those are not the ones who are the biggest problem, but there are some who are willing to engage. So what we do, I know in our courses in San Diego, is we have a final sort of a capstone event for each of our courses. The last meeting of the class, we have put out an open invitation to get 3 or 4 volunteer faculty to attend that last meeting of the class. And they will come from different fields, representing some of the fields that are present in the classroom. And then they answer questions that the students have put together about research ethics, research integrity sorts of topics. And the result of that is that the faculty are representing what's happened in their own environments, which is good for the students to hear from other perspectives in addition to the instructors. Second, they are hearing from each other. So it's always enjoyable to see one faculty member turn to another and be astonished when they hear the other person is doing something, say, you do that? And so this is part of the openness and transparency. You know, for a really good example of that is the topic of whether you should have students review papers that you have been received as a faculty member to review for a journal. And, you know, it is unfortunately fairly common. It doesn't make it right, but it's fairly common that faculty do this without ever notifying the journal editor. And this has resulted in conversations through the openness and transparency aspect of this about how hard is it to ask the journal editor if it's okay, even if it will almost certainly be okay, at least they're on notice so that there won't be a surprise later if that student puts down on their CV that they reviewed for this journal, so that the journal editor was part of the process. Yeah. So anyway, so that's that approach. You said how to involve the faculty, that's what we do.
Yeah, well, it's a great example. We should try it out here as well. That I recently myself was at Radboud University Medical Center in Nijmegen, and they introduced research integrity rounds. Like they have clinical rounds, they have research integrity rounds, and it works well. And it's a bit similar to what you are doing and your example, and it's a great way, I believe, to involve senior staff in this type of activities. Excellent. Now, Mike, time is up. I'd like to thank you very much for being here and showing us all your wonderful, colorful slides and all the wisdom on them.